All right, so I'll just say that again because I forgot to record. This is logarithm 7/3, and this is exponential form. If you have a base to a power is equal to a number, we can switch those numbers around and write them in logarithmic form. The base goes here as a subscript, the power is over on its own side, and the a, or what it equals, is here next to the log. So log base b of a is equal to x. So we're just going to go back and forth here. We're going to switch this one to the log form. So let's say I had 5 to the second equals 25. Y'all agree that's in the exponential form? Okay, we're going to write it into the log form. So I'm going to write the word log. What is my base? What number is the base from this?
It would be 5.
It's the 5, yep. So log, I'm going to put the base 5. The 5 is going to be a subscript. Okay? And then what number is going to go next to the log base 5? We have 2 numbers left. We've got the 2 and the 25. Look at the positions that we have. What needs to go here?
25.
The 25, and that's going to equal the power, which was 2. Okay, and then your calculator has ways to evaluate the logs. There are also different tables that people have figured all of these out, where they're trying to figure out what the power is of an exponent. Thumbs up if you guys think you're okay just going from an exponent to a log form. All right, you're just switching them around. Just make sure they're in the right spot. One thing that I like to tell people is this had 5 squared. I'm not going to put the 5 and the 2 right next to each other, or else you're not switching it around. Like it would just look the exact same. You don't want it to look the exact same. So I'm going to double check doing my loop around. 5 to the second equals 25. I always double check that when I'm picking my answer or I'm writing my answer down. Okay, now we'll go the other way. I'll abbreviate, just put exponential. So they're going to give you a log and they want you to write it as an exponent. So let's just write one with variables. Log base 7 of x equals, I don't know, we can just say y, that's fine. Log base 7 of x is equal to y. You guys go ahead and try to write that as an exponent, and then we'll double check and make sure you got it in the right position. So write that as our power. You can think about using the swoop around method if you want to. And when you think you got it, you can write it in the chat. Yeah, if you do shift 6, that signifies that it's a power. All right, I'm getting a lot of good answers. I'm going to go ahead and do this just to make sure that got it. 7 to the y is equal to x. Okay, did we all get that one? All right, good job. Now what we're going to do is we're going to evaluate logarithms. So what a logarithm does is try to figure out what the power is. So if you just have the log part by itself and you want to know what it equals, what we're trying to do is figure out whatever this base is to some power is going to equal this particular number. Okay, so when we evaluate logarithms, we're looking for the power. And the ones that I'm going to give you are going to be pretty easy to figure out. And if you can't figure them out right away, just try some numbers in the calculator. Like, is it to the second power? Is it to the third power? Is it to the fourth power? So we'll start with some pretty basic ones. I'm going to have us write down 4 separate examples, and then we're going to work them all out. Maybe I'll have you do like the last one by yourself. So we have log base 3 of 9, log base 2 of 16, log base 5 of 125, log base 8 of 8. So when I'm working these problems, and these are the kind that you're going to have to write down. You won't have to write down the ones above when you're doing your homework because you're just switching them and you can do that in your head. But for these, I do want you to write down the exponential statement that you're using to solve it so I know you understand what the concept is behind it. Okay. We almost got these written down? All right, so on our first one, I'm going to go ahead and do my loop around like I did before, but I'm going to say 3 to something is going to give me 9. So that's what I'm looking for. 3 to something is going to give me 9. And Kobe said it's 2. Do you guys agree? 3 to the second is going to give you 9. 3 squared is, so your answer is 2. You're looking for the power. 3 to what power is 9? Okay, so let's try the log base 2 of 16. We have base 2 to some power is going to give you 16. So 2 to what power is 16? If it's not something you know off the top of your head, try some numbers. Is it 2 to the second? Oh, Ernest says it's 4. I think that I agree with that. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So that would be 4. 2 to the 4th is equal to 16. This next one, 5 to something, is going to be 125. Is it 2? No, because 5 squared is 25. Can we try 3? Is it going to be 3? I'm going to try 5 to the 3rd. Does that give you 125? Yep. 5 times 5 times 5 is 125. So 5 to the 3rd is 125. All right, try the last one. 8 to what power gives you 8? Put your number down for your answer. 8 to what power is 8? When you think you got that one, put your answer in the chat. 8 to what power is 8? Yep, and everybody with their answers coming in, 8 to the first power gives you 8. Okay. Anytime these two numbers match, your answer is going to be 1, because that would always be the first power. Any questions on evaluating logs, figuring out what the power is? Thumbs up if we're good for that. Okay. The next thing we do before we graph, this is our last type of problem that we're going to solve before we do a few graphs. These are called common logarithms, or common logs. There are a couple bases that we use all the time, and we use them so much that they get their own like symbol or their own button in the calculator, really. So for these, if we have a base 2, we have to write the 2 to make sure we know it's a 2. If we have an 8, we have to write 8 for the base to be 8. If you have the word log and there is no base, there's an understood base 10. We use base 10 a whole bunch with logs. So just log with nothing, there's an understood base 10. So if there is nothing there, next to the word log, we have base 10. So if you saw a problem and it said log of 100, is there a base that's written there? A little mini subscript? Do you see it on the page? No, if it's not written there, you're going to need to write it in yourself. And what base should we write in there? It's an understood base 10. So we'll write it in ourselves. If you don't see it and you just have the word log, you're going to put a base 10. And now we can evaluate this one. 10 to what power is going to give us 100? 10 to what power is 100? 2. Right. 10 squared is 100. So log 100, that's going to give you 2. On your calculator, you do have just a regular log button, or you have it in Desmos too. You can just hit log 100 and double check. But the log button in your calculator is base 10. So don't try to use it with other bases. We will figure out how to do it later if our numbers aren't pretty whole numbers, but not for this lesson. So that's our first common log, is log with base 10. Our next one is log base E. Remember E from last time? E was the 2.718, the number we use all the time, so it gets its own name for logarithm as well. So our next common log is base E. It's called the natural logarithm. And the symbol or the letters that we use for that, so log without anything written is base 10. If you have these letters LN, it stands for natural log. That's not a 1, that's an L. Natural log, they just switch the letters up, like log natural or something. And you don't have anything written here. This is base E. It's the same thing as log with a base E. But we use it so much, instead of writing log base E, they just use the letters LN. So LN stands for log with a base E. And if you don't know the E so much, make sure you watch the 7172 lesson, post it in Google Classroom, because that will tell you what E stands for. Well, it's just 2.7, and we use it a whole bunch, so it gets its own letter. That's about it. So we'll do one log question, or natural log question, and we'll graph. So if I want to figure out what is natural log of e to the third, do you see the base written there in that problem? Is there a subscript for the base? Nope. So let's go ahead and write it in, okay? Oops, I didn't mean to do the thick font. So I have my base. Now I'm going to write it as my power and figure out what needs to go in that blank space. So e to what power is going to equal e to the third? Anybody think they know? It's not a trick question. E to the what is equal to e to the third?
E to the third.
3. Yeah, it's just 3. So e to the third is equal to e to the third. You just had to know that when you were solving that problem that you have to put the e there. So when you see ln, you have to put an e. When you see log without a base, you have to put a 10. Any questions on the common logarithms and what you need to plug in for your subscripts? We good there? Thumbs up, maybe?
Okay, so why you put that E right here?
Because the ln is what's called the natural logarithm, and they just make that symbol for the problems that have a base E.
But you
So
already
anytime you
had
see
E
an
there.
ln, you put a base E. Huh?
I'm saying, but you already had L and E3, or was that just E to the third?
ln and E are on the same level for this one. There wasn't a subscript down at the bottom. Let me write this E where it doesn't look so janky. You see how these are all on the same level? There's not some little number down here. We got to write that down here. We got to see it.
Okay.
Okay. Because you want to know what the base is, so you can write base to something is equal to this part. We hadn't had any other ones that had exponents, so I can see how you would think that was here and the 3 was there. That makes sense. All right, before we graph the logarithm, I'm just going to go ahead and write what all the transformations are so that you can have those. I'm just going to graph the main, like a log base 2 problem. And then after that, the main way for you to get your answers on this is just to know how it's shifted around. So a log graph has a similar shape to an exponential graph. It's just flip-flopped. So I'm just going to make sure we got transformations first, and then we'll see what the actual picture is for that. So these are our transformations. And we'll sketch a basic one.
Miss Roselle,
Uh-huh.
does ln only have E if there's nothing else?
ln what?
Does ln only have E if there's nothing else?
ln is always E. ln's not used for anything else, yeah. Because the E is the natural exponent and the ln is the natural logarithm, and they're conjoined together. All right, so our original graph that we were going to do is log base b of x, or log base 2, or log base 5, or log base whatever of x. But if you see numbers that are added either at the end or with the x, we're just going to make sure you remember how those shift to graph. So if something is on the inside, remember if it's on the inside, is that up or down or left or right if it's inside with the x? Just like all of our other transformations. Inside is which way? Left and right. Inside is left and right. Remember, left is a plus, right is the minus. And a number added at the end, that's going to shift our graph up or down. So plus k at the end, that's up or down. Up is a plus, down is a minus. So inside, that's shifting our graph left and right. Outside, that's shifting our graph up and down. So just for you to have that at the top. Now what we're going to do is we are going to graph an exponential first and then do the inverse, because exponential and log functions are inverses, because we just essentially switch our x and our y and one becomes the other. That's what we're doing when we're changing all of our stuff around. So for us to graph log, we're going to do log base 2 of x. To graph that, we want to start out by just graphing 2 to the x, and we'll swap our x and our y values. Or we'll make a table for that. That's fine. Or we could just do these 2 tables on the side. So we're going to start with this, and we're going to end up being able to graph our log base 2 of x. So we're going to pick numbers for x that we're used to using when we graph. So we're going to plug in -2, -1, 0, 1, and 2. And then find out the y values. And then we just flip-flop them, x and y. And I'll show you why these two are inverses in a second, just to make sure you understand that part of it. But once you know what a log graph looks like, you don't have to do a table every time. You just think about the log graph, and then you're just going to move it around. All right, let's start at the bottom because these are ones I think you're more comfortable with. What is 2 to the second power? We're plugging this in for x. 2 squared is
4.
2 to the second power is 4. Good. 2 to the first power is 2. 2 to the 0 power is 1. Anything in the 0 power is 1. 2 to the -1. Remember, a negative exponent just puts the number on the bottom, and that is a half. And 2 to the -2, that puts the number on the bottom as well, so that would be a 4. So before we just switch our x and our y, I'm going to show you why these two are inverses. Remember, to find an inverse, you switch the x and y and you solve for y. We did that a couple chapters ago. I'm just going to prove to you why we can do this. If we know these points, we can just swap the x and y and graph them to get our log graph because these two are inverses of each other. Instead of trying to figure out good x values that would go, it's kind of harder to figure to plug numbers in for x than it is to plug numbers in for x here. I'm just going to show you why. If I swap my x and my y, I would have x equals 2 to the y. Everybody see that? If I switch my x and my y, thumbs up, we're good on that? Okay. Now I'm just going to write this as a log, and I'm going to see what happens. If I write it as a log, I think my y is going to get by itself, and that's okay. I can rearrange it as a log. So log base 2 of, this is the same thing as equals x over here, right? I'm just going to put it on this form, just makes it easier for us to see it. Log base 2 of x is equal to y. Is that what we had over here for our other equation? Log base 2 of x is equal to y. Those match? Yes, so all we did was switch our x and our y, and then solve, got the y by itself, and it equaled the other equation. So these two are inverses of each other, which means if I know these ordered pairs, I just swap them, and they would be in the other graph. So I don't have to worry about plotting my own x's there, which you guys don't have to worry about too much, but we're just going to switch our x's and our y's. So 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. Did I do that right? Okay.
Miss Roselle,
Uh-huh.
I know that this is like kind of off topic, but are they doing tests for every class this year or just AP?
Like semester exams?
Yeah.
There's no semester exams. You do AP tests if you have an AP class, but it's not like the last week of school like normal.
Okay.
Uh-huh. Just like we did at Christmas. We'll just end with our replacement test at the end of the year. So we are going to plot the points from our log base 2 of x. We just got them using 2 to the x and swapped them. So my x is a 4th. My y is -2. Just plotting these points. X is a half. Y is -1. X is 1. Y is 0. X is 2. Y is 1. X is 4. Y is 2. So our graph, instead of being a growth graph that looks like this, you know, our growth graphs look like that. 2 to the x would have been a growth graph that crossed at 1. It's going to be this way. It's going to reflect over the line y equals x, our diagonal line here. Sorry, that was a weird burpy thing. And the graph looks like that. So that is your basic logarithm that you guys are going to use as your base before you start shifting it around. There's an asymptote on the y-axis. We don't cross that on our normal one. So if I was going to shift left or right, my asymptote would shift as well. If I was shifting up and down, that one's harder to tell how much it's gone up and down. You kind of want to look at where you cross the y-axis and see where that moves. But the graphs that you have to do, they're all going to be just positive growth log graphs like this. So you're just seeing where it shifts on the graph. So just think about where the transformation is. Okay, they're all going to look like that. You just see, is it gone up and down, left and right, based on the numbers that are here and here. Okay, so that's the one you're going to use every time. And we're just shifting up, down, left, right.